Hey everybody, we're going to start now with standard form of a quadratic function. Now, there's 4 parts to today's lesson. You can see our standards, what our objective is, but I have 4 main parts to the lesson. Part 1, we're going to talk about vertex form from yesterday, chapter 4, section 1. Then we're going to talk about this different form called standard form. Negative b over 2a is super important. We're going to learn how to graph it. Part 3, I'm going to teach you how to go back and forth from standard form and vertex form. So like water to ice, ice to water, melting, freezing, kind of like that. And then part 4, can't learn math without reading a word problem. So we have 4 parts. Let's get started with part 1. Now, this is nothing new. It's just good to go back and make sure we have the foundational groundwork that we need. You can see example 1, hopefully from yesterday, is given to you in, this looks like vertex form. See the parentheses? Now it is a quadratic because it is squared. The vertex will be the opposite of the inside. So I'm going to circle or box that up. The opposite is +3 and exactly the back number of -4. Very dissimilar to what it used to be in absolute values, except it's a U shape instead of a V shape. Again, from yesterday, the axis of symmetry is a vertical line at x equals 3. It has to have the x equals part. The minimum or maximum, we can do this because the a value, see this 2, see how it's positive? That means it opens up, so it has a minimum. So I'm going to write that it opens up, so it has a minimum. That minimum value is, remember from yesterday, the y value of your vertex. That does correspond with our range. You can do the range now or after you graph it. Since I know that it opens up, it's going to be y is greater than or equal to. Remember, we pull the number from right here. Oh dear, that's not what I meant to do. There you go. I don't know what I just did, but that's what I wanted. Okay, so it's always corresponding to this number right here. And this one opens up because a was positive, so I use greater than or equal to. That's my range. This is not a word problem, so the domain is x is all real numbers. Unless it's a word problem, that's always true. How is it transformed from just x squared? Well, the 2 in the front is a vertical stretch. And I'm going to go through those. Let's see, I guess I could probably highlight those in gray as I go through them. So the 2 is a vertical stretch. The -3 is right 3. What else do we have going on? And the -4 is down 4. It's not reflected. Remember, your vertex goes in the middle. So 3, if you're not sure where that's coming from, take a look at my highlight. That's why I put it there. Okay, I'm going to erase that because it's looking messy. Go a little lower, go a little higher, and then you plug them in. I taught you how to use the calculator yesterday. A couple of you were a little hesitant. You can plug them in by hand. So I'll just zoom in right there. So if you want to plug them in by hand, you do this and replace x. If you don't know how to do this, please ask me because it's a huge skill. Make sure to use a minus sign. So if I plug in 1, I got 4. So you can do this by hand. Remember, I also taught you about your y equals button. So you can do 2 times x minus 3 squared minus 4. Definitely worth it. Hopefully yesterday, if you were struggling with that, a couple of you told me, you said, I'm just never going to remember that. That's definitely worth your time to learn how to remember to do that. If you are unable to just plug numbers in, like I can here, call me over. I want to help you. But it is under Shift and Window. And you want your independent to be on Ask. So if you're struggling, that was Shift and Window. Okay? Call me over again if you're struggling with that. So 1 gives me 4. That's good. 2 gives me -2. 3 gives me -4. And 4 gives me -2. And 5 gives me +4. Let's get out of there. I don't need that. My graph will be over 1 up 4, over 2 down 2. You can see the vertical stretch happening. Over 3 down 4, and then over 4 down 2, and over 5 up 4. Pause the video if you need to. I am a quick grapher. Ooh. Make sure it looks like a U shape and not a V. And you can see there that because it's pointing up, that's why the range was greater than or equal to. You can see it goes left and right. Now, all of that was review, but I think it's important because that's going to lead us into the next form. Remember, this was vertex form. Now we move into something called standard form. Now, standard form is still y equals, but we leave it distributed out like this. It looks like ax squared plus bx plus c. And if you're thinking, hey, I've seen that before, you did. In Algebra 1, you learned how to factor these. All right, so it's a little harder to find the vertex, but the main thing is that you can see that there's no parentheses. See how it's like all distributed together? Okay, there's the form. You can see how it's like 3 terms with no parentheses. That's in standard form. Now, here's how and I would say things tend to be in standard form more than vertex form. When you get to physics, if you ever choose to take physics someday, you'll see lots of standard forms here. Kids are actually putting these in their calculator all the time. All right, don't let that, maybe some of you are like, I'm not taking physics. All right, A is the number in the coefficient of x squared. So in this case, it's -2. B is the coefficient of x. Again, -2. A, B, and C. And C is the constant in the back, so 5. Now, to find, remember how a vertex is always a point, right? It's always like H comma K. Here's how you find H, and here's how you find K. X, right? We know X is an H value, or H is an X value, however you want to say that. It's a little more difficult today, so it's not given to you. You have to do -b over 2 times A. You do have to think this through. A double negative makes a positive, and that's 2 over -4. And then you end up with a -1/2 altogether. Now you might have solved that a different way. As long as you got -1/2, that's great. Please watch the calculator because I want to show you what kids do improperly first. Let's zoom in right here. Sometimes kids will just type it in like this. Let's see. They'll do -2, divided by 2 times -2 like that. You don't want to do that because that's not going to give you the right answer. If you're insisting in doing it in one step, you should put the parenthesis here and use a multiply sign there. That way you group the denominator. So if you like doing things in one step, here's what it would be. It would be a -2 divided by the quantity of 2 times, -2. So order of operations, please don't blame the algebra 2 for that. That order of operations, if you don't group the denominator, it's not going to do it right for you. And you can see that that sure does make the -1/2 that I was telling you about. All right, so now we have, and because I'm going to graph it, you know what? I'll make it -0.5. I mean, you can keep it at -1/2 if you want, but I think I can graph -0.5 better. Now, how do we find K? Well, K is a little more difficult here, isn't it? This says you need to plug in what you got. So if you're going to struggle anywhere today, it's probably going to be here. I'll show you how to plug it in by hand, and I'll show you how to plug it in using your calculator. So our equation was, I'm taking a look up at that bold green highlight. It was -2x squared minus 2x plus 5. I'll zoom in there because I like to have my screen a little bit bigger. Now that was the equation, right? Well, what did we just get for x? We got -0.5. So I need to do, remember this is solving for k. Watch carefully, please, okay? I'm going to do -2. but then I'm going to use parentheses and put in negative 0.5. So you're replacing x with h. You're putting in what you just got for h. Minus 2 times negative 0.5 plus 5. Now, you can do that step by step by step by step. But what I was noticing recently is that a lot of kids don't know that your calculator will follow the order of operations as long as you do the parentheses properly. So here, watch my calculator. Make sure this right here, make sure that's a minus sign. Don't let that be a negative sign. Just watch how I'm typing it in. Can you grab your own calculator and try it? You will get 5.5. So this equals 5.5 because my calculator says so. Here's my work for plugging it in. Here's my answer. And that's going to go right here. So you can see that unlike yesterday, you have to work to get your vertex. And just like yesterday, it is the most important part of the parabola. Now everything should be golden from here. Make that a little bigger. Your axis of symmetry is x equals h, just like it was before. Okay, I'm going to erase that because it's getting to be a little annoying. There we go. So you can see there it is, right? Just like yesterday. Let's look at the front. A was negative 2, right? See how the leading was negative? It's going to open upside down. Because it's opening upside down, let's see if it opens upside down because it's negative. That means I have a top, so I have a maximum. And it's the y value of 5.5. And see what else I can do. My domain is all real numbers because it's going to point forever left and forever right. My range, because this one opened upside down because A was negative, it's less than or equal to, what was that number? 5.5. Look at the bottom left. And I'll do my transformations after I do my XY chart. All right, so just like yesterday, once you get the vertex, that will be your middle number. Surrounding it will go down to -1 and -2 on a number line, up to 0 and up to 1. Sometimes kids have a hard time when it's a decimal. So just think of a number line a little bit lower, a little bit lower. I think the calculator is totally worth knowing how to do. So I'm going to go to y equals, and I'm going to type my equation in. Where was it? And I would ask very much that you do this as well. There it is. Pause the video. Make sure that's a negative in front of that too, and make sure it's a minus in front of that too. Oops, sorry. And shift and table. And when I type -2, what is that going to give me? 1. -1, what's that going to give me? 5. -0.5, and that's going to give me 5. So that definitely confirms what I did before. 0 gives me 5, and 1 gives me 1. And maybe an advanced question to ask you is, why do these match, and do you think they'll always match? If you want to answer that and ask me tomorrow what your thoughts and opinions are, I'd be happy to discuss that with you. All right, now, if you didn't like that, because again, some of you yesterday were very anti-calculator, so I'm just going to show you how to plug it in by hand. I'll plug in -2. So some of you did not like using that feature, which is okay, but you do need to realize that this process will be slower without it. So you can see I plugged in -2 and the calculator gave me 1. So if you like to plug it in by hand, you absolutely may, but I just want you to know that it will take you a longer time. Oh, hey, since we have the calculator, if you hit graph, you'll see what the shape is going to look like. So that's what our shape will look like at the end. So instead of hitting table, you can just hit graph and you'll be able to see. Same thing on your handheld calculators, okay? So -2, 1 goes here. Make that a little thicker, easier to graph. -1, oh, come on. -1, 5. Ugh, I hate it when I don't make it big enough. That'd be 4, that'd be 5. That would say it's going to go up here. That's 5. Sorry about that. Oh well, things happen. Darn it. I'm going to try to change yours so that it's actually on the graph. Negative 0.5 and 5.5 goes 1, 2, 3, 4, 5.5. I'll make your graph big enough, okay? I'm graphing mine by hand. Darn it. Oh well, it is what it is. 0, 5, 1, 2, 3, 4, 5, and 1, 1. Don't worry, yours will be fixed, so you'll be able to fit all yours on in, okay? So that way it's just me struggling. There's your quadratic. And you can see we definitely have a vertical stretch because the front number was 2. So I'm going to write vertical stretch. Since my vertex was at negative 0.5, that's actually left 0.5. This one's a little harder. And since my vertex was at 5, 5, that's actually up 5, 5. And because the front was negative, it was reflected. We can talk more about that tomorrow if you need to, okay? But the main idea is that you can graph it, that you can do this part here, the negative b over 2a, and plug it in. So you can see this is definitely harder today. But once you get that, everything else is the same. Okay? So again, can I emphasize to you, please, how important negative b over 2a is, and how important it is that you know how to plug that in. Because without it, we wouldn't have h and we wouldn't have k. And without that, we wouldn't know where to start our XY chart at. Okay, so we have our vertex in the middle and a beautiful graph. Part 3, time for me to teach you how to convert between the two of these. So how do you go from, let's just jump into example 3. So I'm hoping you can see that there's no parentheses in this. So this is actually in standard form. And they want us to put it into vertex form. So I have steps here. First step, tell me what A is. Well, A is negative 1. It's the number in the front. I wanted to remind you that when there is no number, it's a negative 1. B is 3. And there is no constant in the back. Remember, B is what is the coefficient in front of X. And C is the constant. It's bothering me. That's not pink. A is negative 1. There, now I'm happier. So since there was no number in the back, it's 0. Now it's time to find our vertex. So opposite B over 2 times A. Okay, so opposite B over 2 times whatever A is. It's always this formula. That's going to be a negative 3 over a negative 2, which is a positive 1.5. And now I have the task of plugging that in. So I told you to, let's see here. So it's going to be y equals a negative 1.5 squared plus 3 times 1.5. Now all I'm doing, guys, is I took my equation. Remember, my equation was negative x squared plus 3x, and I put in for x. That's what happened there, okay? And now I'm going to grab my calculator, type it in, negative parenthesis 1.5 squared. I would also highly recommend anytime you plug in x to use parentheses. Okay, well, that's my kid, but I told him not to bother me. So I'm going to pretend like I don't hear them. I'm a good mom. So I get a final answer of 2.25. All right, now remember, this is H, this is K. All right, I like how I had all that room in the box and I'm just not using it. And step 3. Now step 3 is we're ready for vertex form. So vertex form is this. Have this as like a flashcard memory, please. And we have to fill in what we got for H, what we got for K, and what we found for A. A is always the same as each other. So that's y equals, what was A? Look up at step 1. It was negative 1. X minus, what was H? H was, let me change color here. I should have changed color here too. So A was negative 1. H was 1.5. And K was 2.25. So it's minus H, which is why I use that, The only other thing you're not going to see, and they'll expect you to know, is that that shouldn't be a 1 there. Oh, and this should be squared. Duh. Sorry. Otherwise, it wouldn't be a quadratic. And I think something that would be cool to do, because I don't think this video is too long yet, yet I say, is putting them both in your y equals. Now you can fast forward this part if you want. I am putting them both in my y equals, and here's why. Oh, I forgot. This calculator got cheap there. I got it because I used to be able to put in 2 equations, and then they wanted money, so I'll use Desmos. Haha. I'm such a cheapskate. All right, here we go. So the first one was y equals negative x squared plus 3x. And the second one was, what did I end up getting as my answer? Y equals negative x minus 1.5 squared plus 2. And if I did my job, you're going to see that they are exactly the same graphs. So you can see that the red, let's see, let's turn it off. You can see that no matter what color I select, that they're the exact same equations. Okay, there's a better visual. And you know you did it right. And that's also a great way to use your multiple choice on a test, is to put them, like, all them in and see which ones are the same. Now we're going to do the opposite. This is given to you in vertex form, and they want you to put it into standard form. So I have steps here. I'm actually going to utilize my boxes. Write it in expanded form. So that's y equals 2 times x plus 5 times x plus 5. If you forget what expanded form means, it means write it like as the square, but write it out. So I wrote it twice because it was squared. That's what expanded form is. And step 2, distribute the binomials. Oof, a lot of tedious algebra 1 here. That's okay. You know how to distribute binomials. I'll change colors. That's x squared. Notice I'm still using parentheses because it's a quantity. I'm distributing. Now, some of you might want to use the word FOIL. I will strongly suggest to you that the word FOIL is not a real math term. But you'll distribute your binomials like I did. You know, x times x is x squared. And what else did I put in there? Distribute A if it's not 1. Okay, so I'll change to green. So boom, 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 boom. If some of you want to combine your like terms now, you can. I'm just going to wait to the end. 2x squared plus 10x plus 10x plus 50 minus 3. And then what do I have over here? Combine your like terms. All right, so highlight. Let's see. This little guy just comes down. These become 20x. And these become 47. So I'm going to go ahead and call upon Desmos to see if I did it right. I do not have an answer key here, so let's just hope that I did. Let's X those out, and let's just see if I did that right. If I did it right, they're going to be the same thing on a graph. Y equals 2 x plus 5, and then a minus 3. I had to square it. Now let's check out this answer I got. I got y equals my answer right here. Let me highlight it just in case I'm not being clear. In standard form, the top one was in vertex form. Okay, so I'm going to take the black off, and you can see that that's the purple one. I'm going to take the purple off and get the black. So you can see, hopefully, that they're the same. And that is because it's like ice and water. They're both H2O. They're both the exact same. One is just in standard form, and one is in vertex form. Okay, so part 3 was being able to go from standard to vertex and vertex to standard. Remember, your vertex is very important. Now, the only reason we should study math is because we should actually be able to apply it to our lives. So I know every time you see a bridge, I know you do. Don't worry, you don't have to tell me. I know that you all see a parabola, don't you? Every bridge you look at, you're like, boy, I can't wait to go tell my math teacher that I see a parabola. Great. That's excellent. I hope that that comes to a point in your life where that is true. Okay? but let's say it's not. Let's just go ahead and look at this anyway. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge, arch being the keyword. You can model that arch. So that arch that I drew in gray, this arch right here, see the arch? Whee! You can model that arch by this equation. And x and y are going to be in feet. Okay? That's actually pretty darn cool. So y is the height and x is length. How high above the river is the arch? When I see how high above something, to me that means, hey, you better be finding your vertex. Okay, I can definitely do that. So to find my vertex, I have to acknowledge that this was in standard form. And then I have to apply what I learned today. The x is negative b over 2a. Remember, that's where we started with standard form. So it's negative 0.847 over 2 times, ew, that's gross, 0.000498. So that's A. Let me make this very apparent just in case you, A, B, negative B over 2A is what I just did. Ooh, I'm definitely going to get my calculator here because, yuck, I don't have an answer key. So that's going to be negative 0.847 divided by the quantity. I'm going to use a quantity here so I don't have to type it in more than once. I think I explained in the previous problem. Just change that to a times symbol. 2 times, oops, where's my 2? I don't want to redo this video, so I'm trying to be very careful. 0. Boom, boom, boom. Okay, I got all my decimals in there. Got negative b divided by 2 times a. Okay. So x is 800. Oops. Close, undo. Oh, where'd it go? Oh, Amy. About 850, I think is what it was. Oh, darn it. I don't have it. Oh, good. There it is. 850.4. This is approximate feet. Now that's x. That's not how high. That's like the horizontal. That's where it happens horizontally. So I'm going to try to move my calculator. There. And that's horizontally. Now to figure out what y is, I have to plug that in. Okay, we can do that. So the equation is negative 0.0000498 parenthesis 850.4 squared plus 0.847 times 850.4. Okay, I'm just plugging it in right up here. See for those x's. I don't know how to make that obvious other than like this is this x and this x. That's where I plugged in 850. And now, because unless you're a superhuman computer, I have to use my calculator. 0.000498 times 850.4 squared. Don't forget the squared. 0.47 times 850.4. So I'm just plugging it in. I'm substituting it in. Aha. So I got 360.1 feet. Now I'm wondering if anybody knows why that's actually wrong. Anybody? Anybody want to share? Anybody want to share? I'll tell you why it's wrong. It's wrong because you're like, I hope you can tell me why. We have to add the height. See how the bridge didn't start? See how it didn't start right on the water? We have to add this amount to it because that's the height we just found. The height we just found was, what was it? 360. So we have to add the 516 to that. And because I truly don't want to screw anything up and remake a new video, I'm going to add 516 here so I don't mess anything up. And the final answer is 876.1 feet from the river. Okay, so that answers the first question. Last question, okay, you can do this. how long is the section above the bridge? And I need to see the picture, which means this calculator's got to move over. I feel like half the video is just me messing with my screen. That's okay. How long is it above the arch? So here is our parabola. We found, our goal is to find from here to here how long is the section of the bridge above the arch. So we're trying to find from here to here. Remember, horizontally, we found 850 to right here, right? Remember how we said the vertex was right here? Well, that happened over 850. So maybe it'd be nice if I put that there for you. So that means that this is another 850 over. So if it's 850 to here, and it's another 850 to there, because it's right smack dab in the middle, what's 850 times 2? That's cute. 850 times 2 is 1700 feet wide. All right, and I'll go through and I'll double check that with the answer key, but I think I read everything right. How long is a section of the bridge? Yeah, we did that. We were able to figure out this one right here, the length of the bridge above the arch. So 1700 feet approximate, because we did a lot of rounding. All right, I hope that worked out well for you. I hope that these 4 things you were able to do. We reviewed vertex form, we graphed using standard form, we converted, and we did a word problem. If you have any questions, make sure you ask when I see you next time.